All right, let's get right into it. Today we're going to pull back the curtain on the 3 fundamental, almost invisible rules that every single AI agent you work with has to follow. These aren't just abstract ideas. This is the very physics of how these models operate.
And let's not beat around the bush. The stakes here are incredibly high. This isn't just a clever saying. Understanding these constraints is literally the difference between building an AI system that's robust and ready for the real world and building a cool demo that just completely falls apart under pressure.
Now, the most important thing you've got to get in your head is that these constraints aren't flaws. They're not bugs that are going to be fixed in the next version of GPT or Claude. No, they are the very nature of this technology. Every single advanced methodology you hear about exists because of these rules. So let's learn how to work with them, not fight against them.
Okay, our first constraint, this one is probably the most counterintuitive of them all. I like to call it total amnesia. You know, the official term is statelessness, but total amnesia really captures it.
So here's the thing. We talk to these AIs like they're a colleague with a photographic memory, someone who remembers every little detail of our project. But the reality? It's more like you're talking to a brilliant world-class expert who just happens to have total amnesia. Every single time you talk to them, it's like you're meeting for the very first time.
You're probably wondering, well, how does ChatGPT remember my name then? It's a clever trick. It's an illusion created by the app, not the model. Every time you send a new message, the application, in the background, is actually packaging up your entire conversation history and sending it all back to the model. The model reads everything from the top, gives you a fresh response, and then, poof, it forgets everything all over again. It's a constant, repetitive briefing.
And this has huge implications for how we build things. Because the model has zero memory, we have to provide it with all the context every single time. This is why having clear specifications isn't just a nice-to-have, it's absolutely essential. It's the model's only source of truth. And it's why we use persistent files, like an AGENTS.md file, to act as an external, reloadable brain for our amnesic expert. It's the only way to give it a memory.
All right, let's move on to our second constraint, which I call the creative calculator. This one gets at the heart of the probabilistic or creative nature of these models. So often, we expect an AI to work like a calculator. You put in 2 plus 2, you always get 4. But that's just not how they work. An LLM is much more like a creative expert. If you ask it for a slogan, it doesn't give you the one correct answer. It gives you a bunch of valid, creative options because it's sampling from a universe of possibilities. And the exact same thing is true for code.
We actually have a way to control this creativity. It's a setting called temperature. Think of it like a dial. If you turn it down to 0, the model just picks the most likely next word, so you get very consistent but maybe less interesting results. Turn it up to 0.7, and you get a nice balance. Crank it way up, and things get super creative but also way more unpredictable. But here's the key. Even at 0, it's never perfectly deterministic. You can still get little variations.
So, how on earth do you build reliable systems with a tool that's designed to be a bit random? Well, this forces a really important shift in thinking. Validation isn't optional anymore. It's mandatory. You have to verify the output. Clear specs help narrow the range of possible answers. And this is exactly why test-driven development is such a superpower here. You write tests that define the concrete outcomes, and it doesn't matter which creative path the AI took to get there as long as it passes the test.
And that brings us to our third and final constraint, the finite workspace. This is all about the model's limited working memory, what we call the context window. We kind of have this fantasy that the AI can see our entire project, right? Every file, every line of code we've ever written. But in reality, nope. It can only see what fits inside its limited workspace at that one moment. It's not looking at your whole computer. It's just looking at the temporary chunk of text you've handed it. Now, to be fair, these workspaces are getting gigantic. I mean, Gemini 3 Pro is expected to handle 2 million tokens. That's like 5,000 pages of text. That sounds absolutely massive, right? But an enterprise code base can be millions and millions of lines of code. It just won't fit. The workspace is always finite.
And what's fighting for a spot in that limited space? Literally everything. Your main instructions, your detailed specs, the entire chat history, the code files you've included, and you even have to save room for the model's own answer. It's a constant battle for real estate. It's a zero-sum game.
This means that probably the single most important skill for a developer today is something called context engineering.
It's all about carefully curating what you show the model. Quality over quantity, always. This is why AI-first IDEs are such a game changer. They don't just dump your whole project in there. They intelligently pick out only the most relevant snippets of code to make the absolute most of that precious context window.
Okay, so now for the really tricky part. These three constraints, they don't just exist side by side. Oh no. They interact, they stack on top of each other, and they create even bigger, more complex problems.
So, let's start by combining amnesia with a finite workspace. The model forgets everything, right? So you have to rebrief it every single time. But its workspace is tiny, so that briefing has to be incredibly efficient and concise. You can't just dump everything back in, you have to be smart about it.
Next up, what happens when you combine that creative, probabilistic nature with amnesia? Well, it means every time you start a fresh conversation, the model might try a completely different, totally new path to solve the exact same problem. Any hope of consistency just goes right out the window.
And finally, we have the most dangerous combination of all, creativity plus a limited workspace. If you give the model vague instructions and only a tiny slice of the information it needs, its creative nature has nothing to ground it, and what you get are wildly unpredictable, often totally useless outputs. This is where so many AI projects go off the rails.
So that might all sound a little bit daunting, I know. But this is where the professional's playbook comes in. All of these modern AI methodologies that you're starting to hear about, they are direct, intelligent responses to these exact challenges.
And this slide basically says it all. You've got statelessness. We fight that with persistent context files and clear specifications. You've got a probabilistic model. We manage that with test-driven development and strict validation. You've got limited context. We master that with context engineering. See? For every constraint, there's a professional-grade response. These aren't just buzzwords. They're the tools you need to do the job right.
So if you take one thing away from this, let it be this mental model shift. We have got to stop thinking of the AI as a knowledgeable colleague who remembers all our work. That's the old way. The new, productive way is to think of it as a brilliant but amnesic expert that we have to brief efficiently, from scratch, every single time. The moment you make that switch in your head, all the frustration just melts away and real collaboration can finally begin.
And that leaves us with one last question for you. Now that you know the fundamental rules of the game, I want you to take a hard look at your own workflow. Are you actually designing for these constraints, or are you just fighting against them? Because honestly, that's the difference between building a prototype and building for production.